Hey, how you doing my friends? Today I'm back with another video on multi-axis toolpath on Mastercam, and we're gonna talk about the 5-axis chamfering toolpath. As you know, a Mastercam does not have any toolpath that call the multi-axis chamfer, so we need to select a suitable toolpath to do the job. We have a lot of toolpath here, and maybe you still don't know which toolpath we can use for the multi-axis chamfer. So this may be a video tip. Yeah, not only a tutorial. Okay. After we finish machine the part, there's a lot of sharp edges need to be chamfered. So for some complicated part, a 5-axis chamfer toolpath is very necessary and very important. With the 3-axis chamfer, you are unable to chamfer some hidden edge like this. So 5-axis chamfer is a good choice. Alright, and you can see on the screen I have a sample part like this. I will use this part to demonstrate the 5-axis chamfering. Okay. You can see this part had a lot of sharp edges, and in this video I'm gonna make some chamfer on some edges, not all the edge up on this part because it take a lot of time, so I just do for some edges. Okay, so back to the toolpath, which is the suitable toolpath to make the 5-axis chamfer. mm, I'm not sure I can answer which is the best, but I have tried with some toolpath and I found that there's a few toolpath can do the chamfer. A 5-axis chamfer, that's the curve toolpath and the project curve toolpath. I haven't tried with other toolpath. I think some other may work, but in this video I'm gonna show you how to make the 5-axis chamfer using the project curve toolpath, because after make some tests with the curve toolpath and the project curve toolpath, I see that the curve toolpath is yes, that work, but we need to modify the park a lot, and it take a lot of time and not so yeah, not so comfortable. So I found another much better way to do that. That's you can use the project curve toolpath. This is fast. This is yes, you don't have to modify the parks a lot, so this is much better than the curve toolpath. Okay, so in this video I'm gonna show you how to use the multi-axis project curve toolpath to do the 5-axis chamfer. Okay, right, we select the project curve toolpath here. Okay, in the first toolpath I'm gonna make a 5-axis chamfer to remove the sharp edge on this surface. Yes, you can see we have a lot of pocket, and we will make the chamfer on the outside edges and the inside edges of the pocket. Okay, for making the 5-axis chamfer, you can select the chamfering tool, or you can select the ball and mill. Yes, this depends on you, it's up to you, but in this video I'm gonna select a chamfering tool, a 6mm diameter chamfering tool to do the cut. Okay, I also have a holder here for the tool, and in this video I just want to talk about the 5-axis chamfer. So this is a project curve toolpath, so there's a lot of other parameter that we don't have to use. Yes, so I just want to focus on the important parameter that can help us to make the chamfering toolpath. So and other not important parameter I will not talk about. So if you want to discover, if you want to make a full understanding, you can click on the help button here and select the see field definitions, and you can click on the parameter that you want to understand about it. Okay, in fact that I have not I don't have a fully understanding about all the parameter here, but I can show you which parameter that can help it to do the job. Okay, so we move to the cut pattern here. You can see on the pattern window we have some parameter, some important parameter. That's the edit curve, the projection direction, the type, the maximum projection distance, the dry surface, the dry surface offset, the cutting side and the cutting side offset. Yes, that's some important parameter that you need to remember. Okay, first for the edit curve we have projection here. We click on this button and we select the edges we want to do the chamfering toolpath. Okay, you can select the chain in 3D mode, in solid mode, or in wireframe mode. Because on this part I haven't created the curve on the edges of the part, so I need to change to the solid mode here in order to select the edges on the solid. Yes, so I'm gonna select the link edges to select the edges that's not lay on the same surface. Okay, I'm gonna select the link edges here. Okay, in ping 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 ping. Okay, it take a lot of time so I don't want to select all edges of the part, just a few edges to demonstrate how to use the project curve toolpath to make the 5-axis chamfer. Okay, I already select outer outer edges of the part, so I'm gonna click on this end chain here and I can select a new chain. Okay, I can select the chain here to do the chamfer on the edge of the pocket. Alright, maybe another one here. Yes, remember to click on the end chain when you finish selecting a chain. Alright, boom boom. Oh, sorry. Oh my god. Right. Okay, so I have 3 chain for demonstration. Okay, after we have selected the curve for the toolpath, the curve we want to make the chamfering, next we move to another parameter. That's either we need to select the dry surface, and you can do it by clicking on the dry surface button here. And Mastercam we ask us to select the dry surfaces. Okay, so what is the dry surfaces? That's the surfaces which can control the tool tip. Okay, in a project curve toolpath, the dry surface is used for controlling the tool tip position, but in this video for 5-axis chamfering we can use the dry surface for control the tool axis also, the tool axis direction also. So if you want the tool stay normal to this surface, this set of surfaces here, you can select these surfaces as the dry surface and also for the tool axis. Okay, because this is a solid, I should activate the solid selection here, and you can see you can shift, you can press shift and select one surface here, And so you can see Mastercam will automatically select the tangent surfaces by clicking and shift select one surface here. Mastercam will automatically select the remaining tangent surface. Okay, so we have selected the three surfaces for the tooltip control and for the tool axis control. Okay, here we have a value, a parameter that's called maximum projection distance. That's the maximum distance from the curve to the dry surface, which which Mastercam can do the calculation. If you input a too small value, some if the curve and the surface has a distance which greater than that value, the projection cannot be done. So to make sure everything is work fine, you can input a large value here, for example 1 millimeter or yes 0.1 inches if you're working on a imperial park. Okay, I input here 5 millimeter for my projection distance, but in fact you can input maybe 1 millimeter or even smaller. That's enough, no need to be too large. Okay, next, after we have select the curve for the chamfer, after we selected the dry surface, we have to select the projection direction. In this case, for the 5-axis chamfer, you have to select the surface normal. So the curve here will be project. The projection direction will be the surface normal, and the type here you have to select the user defined. So Mastercam will do the projection based on the dry surface you have selected. Okay, and you have other parameter that's called the dry surfaces offset. You can see this is the demonstration picture. If you input 0, the tooltip will contact with the dry surfaces, and if you input a negative value, the tooltip will stay below the dry surfaces, and if you input a positive value, the tooltip will stay higher than the dry surfaces. So this is very important. I will input 0 first, and you can see we also have the cutting side offset. This is similar to radius offset when you working on a 2D contour. So I will input 0 and 0. So I will modify this later, so you can see the differences, and you will know the meaning of these parameter. Okay, and for the tool axis control, you can select the output format. If you have a 5-axis machine, you can select 5 axis, and if you have a 4-axis machine, you can select 4 axis. It's up to you. And you can select maximum angle step. You can input a small value for a more precise tool path. Okay, and for the tool axis direction, I recommend you to select the surface. This is the fastest way and the more effective way to do the 5-axis chamfer. You have many other options, but I think the surface is very effective and is the best choice for this situation. So you can use the dry surfaces you have selected before to use the tool axis. Yeah, the tool axis surface. So the tool axis will stay normal to the surfaces you have selected. Okay, and one important thing you need to take into account, that's the collision control here. Normally this collision check on fluid will be activated, and if you activate this option, the chamfering toolpath will impossible to generate. So you have to unactivate this option. You can check the collision on the shaft, the bore, and the holder, but you cannot check the collision on the fluid if you want to make a chamfer, because if you check on this, Mastercam cannot make the right toolpath. Okay, so you can uncheck this collision checking, or you can check on the shaft or bore holder but not the fluid. Yes, so in this case I can remove all of the collision checking. This is very important. If you select the fluid for collision checking, the toolpath cannot be done. Yes, remember that. So in this case I remove. I do not use any collision checking. And for the linking, you can define the lead in and lead out motion for the toolpath here. You can also select the clearance arrow. In this case, I'm select the clearance arrow is a cylinder, and the axis of cylinder is the x-axis, and the radius is, for example, 100 millimeter. Okay, you can check. Okay, we generate a toolpath. Right, you can see. Okay, this is our toolpath. We have the lead in, and you can see the tool direction is stay normal, perpendicular to the tri surface we have selected. Okay, so you can see on this position the tool axis will stay perpendicular or stay normal to this surface at this position. So that is the 5-axis chamfer. Very easy, right? And the tool will retract to the clearance cylinder. So if you want to have a more safety clearance, you can increase the radius of the cylinder here. This is the clearance cylinder, for example 120. Ping. So you can see we have a more safe clearance here. Yes, this is the outer edges of the part, and move to the inside pocket. You can see the tool always stay perpendicular, stay normal to the dry surface. Okay, so we can do the same for the remaining edge inside here. Okay, next I'm gonna make another toolpath to do the chamfering on these edges. You can see I will use the wireframe and create curve on edge to make the curve on the edge, so you can see it's more easy. You don't need to create this curve, but if you create them, you can select it's much more faster. Okay, so in this toolpath I'm gonna make the chamfer on this edge with a 5-axis chamfer toolpath. Alright, you can copy the old toolpath here, or you can select a new toolpath. It's no problem. Bam, 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 bam. Project curve here, and with the same tool. Okay, for the cut parameter cut pattern, for the curve we select projection, and because we have already created the curve here, so we can use the wireframe selection mode here and select this chain. Yes, very fast. Okay, and for the dry surface, because I want the tool to stay perpendicular to this surface, and this surface, So I'm gonna select this surface. Oh sorry, clear selection. If you activate the solid selection here, you should uncheck the body selection. You only check the face selection here, so you can select the surface one by one, not the entire part. Okay. I want to select this surface, this surface, this surface, and this surface, and selection. Okay, very simple. And other parameter will keep the same. And so you can see this is, you can see the tool axis will stay perpendicular to the tri surface at the contact position. Yes, very cool, right? This is the file. Oh, I just forgot to tell you. This just this not chamfering yet, because the tool tip will contact with the curve. Yeah. So the tip is not it have not make the chamfering, right? Because the tip only contact with the curve here. So if you want to make a chamfer, we need some trick. Okay. In the tri surface offset, for chamfering, you can select a negative value. So we want to move the tooltip below the tri surface. For example, I will input -1 millimeter. Okay. So what happened here? What happened now? You can see if I input -1, the tooltip will stay inside of the surface. So we want to move the tool outside. So on the cutting side offset, we can input a positive value. So we move the tool to the left. All right, like this one. And you can select. It's better to select cutting side. You can select center. Oh, sorry. Left side here. With the center, you cannot input the side offset. So you can select left here. For example, I will offset 1.2 millimeter to the left. So until you got a cool chamfer. So you can see now we have a chamfer, a real chamfer. You can see. So you can input. You want to increase this value. Yes. This make a big chamfer. So you need to add more offset to the left. So you can modify the width of the chamfer like this one. You can see here. If the chamfer is still too big, you can you can reduce the dry off surface offset, or you can increase this one. For example, 3.5. You can modify the value until you get a good, yeah. So this is quite small now, right? Okay, I'm gonna select the stock setup, and we select this solid at the stock, so I can demonstrate how the chamfer work here. Okay. Okay. Now you can see the tool make the chamfer and let's go to the surface here. You can see the tool axis will stay perpendicular to the surface we have selected at the tri surfaces. Very simple, right? And if this chamfer is too small, you can modify the side offset value. Okay, for example, you can reduce this to 3 mm, reduce this value and you get a bigger chamfer. Okay, do it again. Oh, where the stock? Where the stock? Oh my god. Sorry. Run it again. Alright. So now you can see I have a bigger chamfer. Very cool, right? Very nice. And I do the same for the toolpath here. The first toolpath I forgot to modify the surface offset, the dry surface offset, also the cutting side offset. And so you can check if we got a good chamfer here. Yes. Alright. And someone will ask why I can why I don't why I didn't make the chamfer on this surface and the chamfer on this surface in one operation. That means you want to combine this one, this toolpath and this toolpath in one operation, in one toolpath. Is it possible? Let me check. Okay, so for the toolpath here and on the curve, I will add more curve, so I will add this one. And for the dry surface, I select, after select these surfaces, I select this one, this one, this one, and this one. So let's see what we got if we combine the two operations. So you can see there's a crazy move. Yeah, you can see that, because you know why? Because for this curve we have two dry surface. Let us show you. Yeah, because for example this curve here, we have this surface and this surface, so Mastercam don't know which is the right dry surface for the tool axis, so the tool will go crazy. So that's why I split this curve in a one toolpath and this curve here in one toolpath, so to make sure there's no dry surface for one curve. Yes. So for making the 5-axis chamfer, you need to remember that one curve is only controlled by one surface. Yes. If you select this curve and this surface, Mastercam we don't know which is the right surface to use as the tool axis control. So that's why I split it into operation like this. Okay. And this is the part with it's a solid model with we don't have the chamfer make already on the toolpath, sorry, on the solid. But how about if you have a part like this with the chamfer already made like this on the solid? It's not much different. I will show you how to do it. we just change the side offset value. Yeah, so I'm gonna select a new curve. Okay, for example, this solid had the chamfer already made on the solid. It's not like the same, it's not similar to here. We have sharp edges. You can see this, we already make the chamfer. I set the edge here. Oh, you can see we have a gap here because the solid data is not good, so we have a gap here. So we are unable to make a continuous selection. To solve the problem, you go to the wireframe and click on the chain option here. You can increase the chain tolerance here to a larger value, and you reselect the chain. That's cool, right? You can see Mastercam will skip the gap because we increase the chain tolerance. That's good. Yeah, if you haven't created the curve, you need time to select one by one edge like this. So I recommend that you should create a curve on the edges first before you making toolpath. Okay. Sorry, I forgot to select the dry surface. We don't use the dry surface here because the chain here. So we remove the old surface and we select the new surface. Oh, Okay, if you want the tool to stay perpendicular to which surface, you should select the surface you want. That's control the tool axis. Okay. So you can see here we have the same result, but because the chain is go further into the surface, the chamfer will be very big. So you can modify that by yeah, you can increase this value, the inside offset. We increase to 4. So you can see we have a good contact here. Yeah, so no problem if your solid already have the chamfer, you just change the value of the offset here. Yeah, you can change the value of the side offset, also the dry surface offset, and you can guide the tool into the right position, and you can control the width of the chamfer. Okay. And I have another part here. Yes, I have another part here. You can see this is another sample. I can hold the part on the fixture like this. We'll clamp here, and the fixture we clamp on a chuck like this one. And you can see I have the project curve toolpath. And yes, and use the same way to the part I made before. So I'm gonna show you the curve and the dry surface I selected. For the curve, you can see I have the curve, one curve here on the yellow and one here. On the top, yes. And the dry surface, You can see I use one dry surface for this curve and this curve, so the tool will move in the same direction. Yes, this is the case. We can use one dry surface for more than one curve. Yes, this curve and this curve use the common dry surface, use the same dry and tool control axis. Okay, so you can see we go this way. So the dry surface will control the tool axis. Yes, and in this side we go like this one. Alright, so the tool will not collide with the picture. This is for the bottom of the part. I will use these surfaces to control the tool axis. And for the top face, I will select another tool axis control, so the tool will stay perpendicular to this surface. Yeah, not lie with the bottom. Okay, like this one. You can see you have many ways to control the tool axis. Okay. So you can also use the multi-axis link toolpath to connect more than one operation. Yes, I use the multi-axis link toolpath to connect the number 1 and number 2 toolpath into one toolpath like this. Okay, and let's see it's on the machine simulation. Oh. Oh. Sorry. I need to reselect the stock. Wow, this is a long video. Okay, go to the machine and hide some okay, we can hide the door. Oh, collision start. Okay, go in. So cool, right? Yes, and this is the 5-axis chamfer. Very simple. Yes, very simple. With the project curve toolpath, you can do the multi-axis chamfer. Okay, and that's all for today. See you again. Goodbye for now.